Okay, so we're now at the point where we have to hook up the actual USB port to the Peltier generator.
Yep.
Say hi, Justin.
Hey, Dr. Potoff.
Okay, so we're starting with a lower voltage phone because we're still troubleshooting, trying to get high enough voltage. Also, we don't want to use our phones because we don't want it to short out and mess up our electronic devices, which are very expensive. We're basically going to take this. This is actually from a car charger port. We just kind of took it apart and took the spring and stuff out of it. So we just kind of took this all apart, and now we're just left with this. And then these ends right here are going to be the positive and negative. We have a heat sink. It's 100% aluminum, and what the heat sink is going to act as, it's going to be the cooling portion of the Peltier module generator. And basically this tiny slits just kind of allow for more heat transfer.
All right. Right here. Very expensive. So we're using thermal glue to keep the what's it called again?
Heat sink.
The heat sink with the module and the copper. So we need it. In order to keep this intact, we have to use thermal glue.
And it's conductive. The glue is important to have that type of glue, the thermal compound, right, because it helps with the conduction of between the two metals, the copper and aluminum, and right, also the Peltier module. And we're still working on trying to get the not the conductivity, but the voltage up a little higher. We're currently at 0.33. If we wait like another 60 seconds or so, it'll probably go back up to 0.4. Hopefully 0.5. So right now we're actually testing out different ways to try to get the voltage up. And what we decided to do is take the stainless steel bowl, put some ice in it so that the heat sink will be able to cool off a little faster, and also help with the temperature gradient between the copper and the heat sink. The other thing we decided to do was,
as you can see, the voltage is increasing rapidly.
It is.
Just by using a stainless steel filled with ice.
So yeah, it's actually, we have 0.5, so that's the highest that we've had since doing this. And also the other thing that we did was decide to just take a lamp and shine a lamp on it. And we're using the lamp because there's no sunlight outside, honestly. And if it was a hot summer day, the lamp would kind of be analogous to it being hotter. If we look back over here to the the voltage is still going up. Yeah, it's slowly but surely increasing. So I'm assuming that the ice and then the lamp is helping the temperature gradient out a lot. Probably gonna put some more ice in there. So in a second, we're actually gonna hook it up to our USB port and try to see if we can get some results that way with charging the phone.
Okay. So as you can now see, we have the phone hooked up to the Peltier. Peltier. I'm sorry, the Peltier module. So do you want to say the charger?
No, it's not charging.
Okay.
If you look at the phone, you know it's hooked up to the USB and the port. It's not charging up, and it's obviously because it's not enough voltage. A phone like this probably needs about at least 3 volts to charge.
Yep.
So we know we probably won't charge up an iPhone or any of the modern Androids.
Smartphone.
Yeah, smartphone made within the last 2 years. This phone is maybe...
It's about 3 or 4 years old.
Yeah, it's like 4 years.